web applications in C++. How many people have written a web application in C++? Okay. One person. Interesting. Cool. So that's what we're going to cover today, and I'm going to talk about a technology called native client, which is started off as a research project in Google, and over the last couple of years, it's really blossomed into an actual product that's going to be built inside of Google Chrome, the web browser. So first we'll talk a little bit about what native client is as a technology, how this is possible, how can you run C++ in a browser. We'll talk about the SDK, which is something we released earlier in the summer to sort of help application developers use the native client tool chain to build these modules that you can embed inside of a web page. We'll look at the anatomy of what a module looks like, a native client module, in the process of sort of building this MVC framework, this application layer that sits on top of JavaScript and HTML and CSS and HTML5, obviously, and then bridges the gap and goes into C++ to do something really interesting, and then comes back with the result. So we'll take a look at a calculator, it's a calculator application. It's going to be really simple. Not a great use case for this technology, but it does highlight this MVC, model view controller paradigm. And then we'll take a look at some demos, because demos are always cool, just to get your mind thinking about what this stuff can do. So without further ado, native client. You're going to hear me call it NACL, N-A-C-L, which is also the formula, right, for table salt. But I assure you it's much, much more than just table salt. So the vision here, let me just present this to you. What if you could run a web application and take advantage of the user's CPU, the full potential of the CPU, run on any platform, so Linux, Windows, Mac, run it in a web browser. So this is all the properties you love of the web, right? What if you could write that once and run anywhere? And that's a Java quote, but what if you could do that in C++? And that's really what native client's all about. So running on 32-bit, 64-bit ARM architectures and running on all those different platforms, but still keeping the philosophy of the web. So the web is very open. The web is portable. You can access JavaScript files, web apps from anywhere, anytime over the internet without installing these applications. And that's what native client's all about. So when I say write once and run anywhere, that really means that we can take advantage of decades and decades and years of development of libraries such as Qt and frameworks, OpenGL, ImageMagick for image processing, and compression libraries. All this great stuff that when you develop a desktop application, you're going to be using. But let's do that now inside of Chrome, inside of the browser. That's an interesting concept. So again, what if you could run native performant code, right? C++. This is going to be fast. This is taking advantage of the user's CPU, the full potential of the computer, on these different architectures, so x86, 32, 64-bit, and the ARM processor. Clicker. Again, on different OSs, so it's portable. It's completely portable code. You can write this code once, and it can run anywhere. And it's inside of the browser. So it's not an installed app. It's not a desktop app. It's a web app. So what do you get? What do you get when you build this cool stuff? Well, the first thing that comes to mind are games, right? 3D games are, how many people play games all the time? I know I do, right? So the example here in the left corner isn't actually a native client game. It's the port of Java to JavaScript of the Quake 2 port, which is an open source project and uses things like WebSockets and JavaScript. And it's fast. It's pretty good, but it's not great. The performance is a little slow. The frame rate isn't that great. The port over here is of Lego Star Wars, and we actually show this at Google I/O. Oh, okay. We show this at Google I/O, which is this is a game that runs on the Unity game engine, which is a plugin for the browser. But what they actually did, we worked with them to port their game over to native client using our technology, and it's actually just as performant as it would be if you installed it off the shelf, via a CD inside of your machine. And unfortunately, I'm not going to be able to show that to you today because for whatever reason, Chrome, the latest dev builds of Chrome are not supporting 3D graphics right now for me. So no 3D graphics, but you'll see some 2D stuff, which is pretty cool. So the game looks and feels exactly as if it were installed. So here's the technology in a paragraph. And this is pretty complex, so I'll just read this. What is native client? Well, it's a sandboxing technology for safe execution of platform-independent, untrusted native code, meaning C++, inside the web browser. So it allows applications that are computationally intensive to interact and leverage the resources, the full potential of the user's computer. Yada, 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 it goes on. So what does this mean? This is kind of confusing. If you take anything away from this whole talk and what native client is as a technology, it's basically a sandbox for running C++ safely. So, when you install desktop applications, right, they can pretty much do anything they want on your computer, right? They can nuke your hard drive, they can open up socket connections, send data. Maybe they're doing things maliciously. You just don't know. But what native client does is sandbox all of that. So only certain instructions will actually run inside of native client. Anything a web app can do, native client can do, and no more. So, for instance, an HTML5 application can't open up socket connections. It can't do file I/O. A native client can't do that either. So you're within Chrome, the security sandbox of Chrome, right? And you're also in the security sandbox of native client. So you have this sort of double layer protection. And again, it's in the web browser. You're running C++. So here's sort of a diagram of all that mess. This confuses myself, but the right side here is basically a diagram of how Chrome works as a browser, right? So so the middle section there is the main browser process. This is the thing that's going to manage the tabs. When you open a tab, it's going to do things like open up connections. And then so each of these green tabs are the trusted code. So this is something Chrome trusts. When it opens a tab, it's going to trust that. And within that tab, which is a separate process in itself, is your native client plugin. And native client is just a plugin within inside of Google Chrome using the Pepper and NP APIs. So with inside of your plugin, you're going to be running your native client module, which is abbreviated with a NEXE. We'll call it a NEXE module. So I've sort of given you the vision and set this up a little bit, for native client. So what is it really good for? Well, I think right now it's at a place where it's sort of maturing as a product and as a technology at Google, and will be part of Google Chrome Stable later this year. But what's it good for? Supporting desktop applications is an obvious one, right? You have these legacy applications that you're using regularly. Make them web apps. What a great idea, right? You can access them anywhere now. So there's zero install. Native performance, you're going to get the speed and potential of a desktop application inside the web. So games, large media, physics engines, stuff like that, visualizations, 3D, 2D graphics. So you can really enhance existing web apps with this. So you're writing your front end right in CSS and JavaScript and HTML, and then maybe you send it off. Your application does something computationally intensive in C++. Again, you can take advantage of years and years of development in C++ in libraries, and it's just a different choice, right? People do Java, people do C++. There's a lot of great stuff out there for that. And so the last point here is again, the sandboxing of this architecture. So all the code that's run in native client is sandboxed. And so basically what happens is, how many people have seen a confirmation like this, right? A confirm installation. Nobody's seen this? Nobody's installed a plugin on their browser? So this is I just made up the text here for this, but basically when you install a plugin, right, it has more privileges than it normally would. So like the Flash plugin, for instance, can access your camera, can access parts of the hard drive and do connections and whatnot. So native client basically puts an end to this, which is a dialog for installing a control. So let's talk a little bit about the SDK and how you can actually build a native client module. So the SDK, some of the goodies that are packaged with it, basically wraps up the native client tool chain. You get things like standard libraries, the GNU libraries. We have a special version of GCC and GDB for debugging. There's the Pepper APIs. So the MP APIs and Pepper APIs are basically APIs, if you're not familiar, with the way the APIs that the browser implements. So for instance, if you have the Flash plugin or another plugin, these are the APIs that are going to talk to that plugin. So you can do things like audio and video. You can capture mouse events. You can do things like 3D graphics with OpenGL. Another part of the SDK is this interop layer. So I'm going to show you some code in a bit, but we call it sea salt. So there's Pepper, there's sea salt, there's NaCl. It's all kind of huge puns, but we like the naming. So the JavaScript layer is the one that bridges the gap in between sort of the external world and the internal native client world. And lastly, there's, of course, a bunch of sample code. There's build scripts to get you started for just about everything. So let's take a look at a sort of a tutorial and walking through what a native client module looks like. So how do you get a native client module onto your web page? Well, first thing you do is just HTML and some script, some JavaScript. So what I have here at the top is just a normal div container. We'll call it native client container, and that's going to be where the native client sort of module is on our page. Next, we'll just load. We'll actually load the module from a web server. So this could be any server on the web, hosted anywhere. We'll give it a URL, and it's just compiled as a .nexe file, an .exe file. And we'll just embed this as we would a normal sort of plugin or object on the web page. So I'm just getting the native client container, the div element. I'm setting the inner HTML to an embed tag. I'll give it an ID. The width and height of this tag are going to be 0 because we're not going to be rendering anything inside of it. It's just going to be sort of running in the background. We'll give it a type. So the type is a Pepper application. It's going to be talking to the browser. And an onload event. So when this thing's actually loaded, we do something pretty silly in this case. And just call onModule load, which just is going to say, hey, the native client module is loaded. Nothing special there. The last thing we need to do is set the .nexe's property of this embed tag. And the reason behind that is because of this bug, for one, and also because if you're compiling a native client module for different architectures, it's impossible to determine what architecture it's being run on inside of the browser. So in JavaScript, there's no way to determine if you're on a 32-bit machine or 64-bit machine. So we actually bake this into Chrome as a feature. Well, it's going to change a little bit, but you can see that I've compiled a different module for each of these architectures, and that's all that's going on there. So calculator. The very first thing we're going to do is write the UI for this, and the UI is just going to be C++. It's going to be JavaScript. And that's going to talk to the Pepper layer. The Pepper layer is the one that's going to be communicating to the native client module and the plugin itself. Inside of that, just to recap, is the native client sandbox. This is running our untrusted C++ code that the developer has written. And that's the native client module. So here is the sort of JavaScript of our calculator. And here's the reminder of where we are sort of in this stack. So we're just going to add some HTML and CSS and JavaScript. We'll create a start calculate method. Nothing too special there. And as you can imagine, it's going to take an input from this calculator input field, this just a normal text field. And so we're going to just create a postfix expression based on what the user has inputted in our calculator. There's a bunch of code that does that processing, just creates a postfix expression out of that input field. The reason I'm doing this in JavaScript is because it's a lot easier in JavaScript. All this manipulation in C++ would be a little bit more difficult. So, and there's no reason. JavaScript is extremely capable of doing something like this. So that is the parse expression function there. But the important part of this little section here is the calculate module, right? So we're creating this calculator object, which is our embed tag. It's just a DOM reference. Calling application.module. And there's this CSalt library is part of this bridging layer. So this is going to be a reference to our native client module in JavaScript. And the first thing we do when we try to execute maybe an expression, a calculator expression in this application, is that it's going to try to call the calculator module.calculate. It's going to pass it our expression that the user's input and call a callback function, the onCalculate. Now that's going to fail because we actually haven't defined our calculate method in C++ yet, right? So we're going to hit that try catch, and then it's going to call onCalculate, and the result's going to be 42, I think. So no matter what we do in the calculator, it's just going to return some bogus value. So before we add the C++, let me just show you what this thing currently looks like. That is the wrong one. Calculator 1 is what I want. So you'll notice nothing's special about this. This is just using HTML. I can even zoom in on this. HTML, CSS around the corners, gradients, just a normal input. And these are all buttons. So I can type 5 plus 5. And when I press equals, it's going to say, as expected, 42, I think. Cool. So we have a calculator that's completely broken. So obviously now what we need to do is get to the meat of this and add actually some C++ that our native client stuff. So the first thing we can do is create this calculator object and initialize some methods. So these are the methods that we're exposing in JavaScript. So you can see the bridge at the bottom there, bridge add method name and calculate. That is how we're adding our calculate method in JavaScript to our C++, so it recognizes it. We'll create up a callback function, and this callback function is a reference to the the JavaScript on calculate method that we're passing in our JavaScript. And that'll take the bridging layer as an argument. It'll take our expression, and then the return value will be set by this sort of C++ calculator, this calculate method. So just to remind you, back in our JavaScript, right, in the front of this application, we have that calculator module.calculate that takes the expression, and that on callback in JavaScript is that in callback also in C++. So back to C++, we're creating our next module. There's far too many fancy animations in this slide deck. But the bulk of this is not that interesting, actually. So there's this first evaluate expression part, and that's going to take that postfix expression, the input, and just create an array based on it. The last thing we do when we calculate this, and 5 plus 5 in C++, that's not too difficult, right? But again, this is just demonstrating this sort of different layering here. The last thing we do in this method is called the Pepper APIs, which is npm invoke default. We'll pass it the function, the object that we get back, the actual value to our C++, or excuse me, our JavaScript method on callback. So if that makes 0 sense to you, basically what it means is that we just called the onCalculate method in JavaScript from C++. And this time, hopefully, the result will be passed. C++ will have done the calculation for us, 5 plus 5, and then hopefully there'll be no errors, and we'll just set the formula.value on that text to the result. So let's see what that looks like. By the way, I've already pre-compiled all these modules. So you can see in this case, right, the first demo, the Calculator 1, just had the UI. There was no native client module tied to it at all. In this case, we actually have the module loaded, right? The embed tag is there, so we're just alerting that the module is finished loading in this case. So hopefully, if we've done everything right, if I type 5 plus 5 in now, we'll get 10. So that's cool, right? That is JavaScript talking to C++, C++ doing the calculation for us, and then throwing that back to JavaScript. And just to prove to you that this does work, we can do more complex. 45. Cool. So it does work. You take this one step further. I don't actually have the code to show this to you. Whoops. Did I mention it was still somewhat of an experimental technology? Do we have a sound? Can you guys hear that? Okay. Can you hear the button clicks? Does it work? I can't hear it down here. But basically what's happening here is we're sampling sound in C++. And we're taking the JavaScript events, we're processing the clicks, and then the C++ is rendering and displaying or processing that audio when I click a button. There we go. I can hear it. Who knows the answer to this? That's what I thought. Okay. So that is sort of the anatomy of a native client module, a native client application. Before I show you some other demos, I'll just sort of finish up the slides here. Coming attractions. So at this point, we're sort of we're still building this out for developers. This is sort of an evolving technology. We do have full debugger support with GDB, but nobody wants to debug in GDB anymore. We have better tools. We have things like Visual Studio. We have IDEs like Eclipse and Xcode, right? So we're going to start to work with it's actually an open source project, right? So we're going to start to work with developers and internally to develop some of these things. So we actually have an implementation of Visual Studio compiling and debugging a native client module, which is really cool because you get all the fanciness of the IDEs. The last point I want to mention here is a project, a similar project called Portable Native Client. And what Portable Native Client is a way, you remember you saw the different modules compiled for the different architectures, so 32-bit, 64-bit, and ARM. PNACL, or Portable NACL, is a way to combine all those into one. So you can basically you write your code once, and it's ported over across all architectures. So that's a pretty cool idea, at least in the C++ world. So a summary of sort of what you saw here today. Basically what Native Client is, it's a way to run native performance C++ in the browser using Google Chrome. And what that opens up is a choice of language. So you can run C, you can run C++, you can use libraries you have, you can port a desktop application, but you can also do assembly. You can also run Objective-C or Python, right? Those are all based on C. And we actually have an implementation of Python running inside of Native Client, which is really, I don't know about you guys, but Python is my favorite language, and that's pretty exciting. So you can take full power and advantage of the client CPU. You maintain browser neutrality, right? You get all the properties of the web inside of a native client. And you provide a safe sort of execution space for web apps. So a couple resources. This is the top one here is the project page itself. This is native client, the source code. But if you're actually developing an application or interested in developing an application in native client, you should take a look at the Google Code project for the native client SDK. And that's good. A getting started guide. It's got samples. It's got the tool chain. It's got everything. So that should get you started. The last link here is just sort of an overview of the technology and on chromium.org. This is the sort of Teams project page. How much time do I have? Like a minute? 1 minute? All right, I'll show you a few more demos just to get your minds thinking about what some of this stuff can do. Granted, these are sort of sample demos. So here's an example, if it loads, of using Qt in native client. Well, that doesn't look good. Hold on. I told you graphics wouldn't work today. Okay, so that's an example of a blank web page. Let me do this one here. This is a demo we did at Google I/O. This is basically a text-to-speech engine. So anything I type in this text area, if you can see that, it should...
Welcome to Google I/O. We hope you enjoy the show.
So it should do the text-to-speech for us, and that's using native client again.
Charlie, Delta, Echo, Foxtrot, Charlie, Alpha.
What else? An example of doing 2D graphics. This is calculating pi using Monte Carlo approximation, using Canvas. Not that exciting. You could do this in any language. C++ probably isn't the best option for this, but again, a good example of the computational power here, and offloading that to native client. Let me try this one again because this is a good one.
Alpha.
There we go. So this is Qt rendering this, and I can flip them around and animate them, transform, pixelate. But if you look at the source of this page, right, it's exactly what you saw before. So there is no canvas tag on here. This is rendered in the Pepper APIs using native client, and you can see at the bottom there the same thing I showed you before, which is the embed tag loading the modules itself. Cool. So I think I'm just about done, unless there's one more that I can show you. Here's an example of just a silly drawing application using the 2D APIs of Pepper. And this is just rendering the graphics out to a canvas tag in this case. So here's your module, and here's your canvas tag. Time is up. All right, I'm all done. Thank you. If you have any questions, I'll feel free to ask.
有人有问题想要发问吗？哎 ，a question.
A simple question. The interface look a bit, say, complex compared with, say, Java's JNI. Do you have any plan to simplify that?
It is complex. I think C++ is generally complex. One thing that I've noticed, I'm a web developer at heart. I'm not a C++ developer, and looking at that code for me is very complex. But what we're doing is the sea salt layer that I sort of described, the layer that bridges the gap in between JavaScript and C++, we're going to make that feel more like Java. There's also a web IDL sort of library that we're going to use, so you can actually do DOM manipulations within C++. So it's going to feel a little bit more web developy. From a web developer point of view, it's going to feel a little cleaner. But at the same time, it will be complex. This stuff, like if you're porting a library, right, it's going to be everything it was originally in the source. Hope that answers your question.
还有人有问题吗？
What license is it released under?
The native client source code?
Yeah,
That's a great question. The project page itself should say, but I don't want to give a wrong answer without knowing. So someplace on this project page it does say, but I won't bother looking it up right now. But if it doesn't,
B.S.E license.
It does. Yes. Okay. Oh yeah, at the top there.
So currently you're supporting only 3 architectures.
So right now it's x86 and ARM.
Okay,
that's
so
right.
that's not, for me that's not run everywhere. So how do you plan to support other architectures?
Right now they're focused on x86 and soon to be ARM for like netbooks. There is the case. Okay. What other architectures would you like to see?
Well, Debian supports 11 architectures.
Okay.
Okay, I run a netbook that runs MIPS, for example.
Right.
And
right.
there are different kinds of MIPS actually. So
sure. Right now, I mean, the target is the sort of the mainstream, right? And x86 is the big one.
So basically, by doing these kind of things, you're actually breaking the webs, making some web pages not run on other architecture, unless you have a plan to support these architectures.
Well, I don't think we're breaking the web. I mean, we're augmenting the web with different capabilities,
well,
right?
It's the same. I've been censored.
Sorry, I think
I say it's like Flash. That say they run everywhere on all they're multi-platform where they're not. So if you run, what everybody buys, and you go into the lobbying and the bad business practices of Intel and Mac, it's fine. If you buy something because you want to run another CPU, then it's not so good.
No, absolutely right. And it's still a project that the team is actively developing, right? I mean, this is where we are at this point. Give it a year, who knows where we'll be, right? The team is ever growing, and so yeah, we'll see. It's one of those things that'll take off if the technology is promising and people start developing on it, and we see how interesting applications can be built on top of it. We'll get more resources, and other browsers maybe will adopt the same technology, right? So right now it's going to be a feature of Google Chrome, and then maybe in the future it's a feature of other browsers, Firefox, Safari.
Actually, you have 2 issues. You have browser support and CPU support. So it's
okay. Well, we can talk offline then. I mean, the web is a broken place in general, right? So, yeah.
You mentioned that you are going to support like Firefox or other browsers. I mean, will you turn to be part of WebKit project or will be?
You said WebKit?
Yeah.
So I mentioned that if the technology is compelling enough for other browsers to implement it, they will. Right now, well, actually, the team did put together a module or an install plugin for Firefox originally. Since that, we've gone to just Chrome. So for the initial release, we're only going to support Chrome. That's going to be the browser you can use native client in. If developers, want to develop really slick applications, and other browsers will start seeing how cool this stuff is and the compelling use cases for it, then they'll do that.
So both desktop and embedded platforms.
I didn't catch that. Sorry.
So both desktop and embedded platforms. I mean, for example, Android platform as well.
Yeah, it's hard to hear, but the speaker's not that great. So. But we can talk afterwards if you'd like.
好，那这个时间也到，我们再以热烈的掌声谢谢 Eric。